So I'm dedicating an entire video to this because this is a very common exam question. They really like to ask questions combining partial fractions and integration, and when they do ask it, there's a lot of marks available, so they're really important questions. Now in this video, I'm not going to go through in detail how to do partial fractions, as I already did a video dedicated to this back in year 2, chapter 1, so go back to that if you need a reminder of how they work. But here's a typical exam question in this fashion. Okay, so for part A, we need to express 5x plus 3 over 2x minus 3, x plus 2 as partial fractions. And as we have two brackets here in the denominator, we're going to split this up into two partial fractions, one of them having this denominator of 2x minus 3, and the other having this denominator of x plus 2. And we're going to call the numerators a and b, where a and b are constants, and we need to find what a and b are. So we have this equation here, and what we're first going to do is we're going to multiply all the terms in this equation by this denominator here. So we're going to multiply all the terms by the two brackets, 2x minus 3 and x plus 2. So if we start with this term here, this denominator is just going to cancel out and leave us with the numerator 5x plus 3. And then if we consider this term here, this 2x minus 3 bracket is going to cancel out with this 2x minus 3 denominator and leave us with a multiplied by x plus 2 like this here. And if we consider this term here, this x plus 2 bracket will cancel out this x plus 2 denominator to leave us with b multiplied by 2x minus 3 like this here. So we're left with this equation. Now, as we talked about in the partial fractions video, there are two ways in order to solve this equation here for a and b. You can either use substitution or you can use equating coefficients. Now in this video I'm only going to go through substitution because I think that's the way that most people prefer. It's the way that I prefer as well, but you can use equating coefficients if you want to as well. The way that we use substitution is these two brackets here. What we're going to do is use substitutions for x to make these brackets equal to 0. So if we start with this x plus 2 here bracket, we want to make a substitution. So x plus 2 is equal to 0. So if we move the 2 onto the other side, we get that x is equal to minus 2. So we're going to make the substitution here that x is equal to minus 2. And if we do this, this bracket here will be equal to 0. So therefore this whole term here will go away, and we're just going to be left with an equation for b, so therefore we can solve for b. So if we're subbing in x is equal to minus 2, this x here is going to be minus 2, so it's going to be 5 minus 2 plus 3. Then this term goes away, and then we're left with this term here, so it's going to be b, and then 2, and then x here is minus 2, and then minus 3. So we can simplify this because 5 multiplied by minus 2 is minus 10, and then plus 3 is minus 7, and then 2 multiplied by minus 2 is minus 4, and then minus 3 is minus 7. So we've got this minus 7b, and then we divide both sides by minus 7, so we get that b is equal to 1. So we found what b is, so now we need to find what a is, and the way that we're going to do this is make a substitution so that this bracket here is equal to 0. So 2x minus 3 is equal to 0. So if we move this 3 onto the other side, we get that 2x is equal to 3, and then divide both sides by 2. So x is equal to 3 over 2. So we're going to let x equal 3 over 2, and then if we do this, this bracket is going to be equal to 0, so therefore this whole term here is going to go away, and we're just going to be left with 5 and then 3 over 2 like this here, plus 3 is equal to a, and then it's going to be 3 over 2 plus 2 like this here. And then this here, if you put this into a calculator, it's equal to 21 over 2, and then this 3 over 2 plus 2 is going to be equal to 7 over 2, so it's 7 over 2a, and then if you divide both sides by 7 over 2, you get that a is equal to 3. So we found what a and b are, so therefore we can write this fraction here as the partial fractions 3 over 2x minus 3 plus 1 over x plus 2. Okay, and then in part B, we need to find the exact value of the integral between 2 and 6 of this fraction here. We need to give our answer as a single logarithm. Now, the problem with this integral is we cannot directly integrate this fraction because it's too complicated. However, in part A, we showed that this fraction can be split up into these partial fractions here. So therefore, we can rewrite this integral as the integral between 2 and 6 of these partial fractions here. And what's good about this is we can directly integrate these partial fractions here. So therefore we've made this a lot easier and we can actually solve this. Now this is a definitive integral, and I've talked about this before with definitive integrals. These limits here, 2 and 6, we don't actually need to worry about them for now. Firstly, what we actually need to do is integrate this 3 over 2x minus 3 plus 1 over x plus 2, and then we just plug these limits in at the end. So let's firstly focus on integrating this. So we have two terms here. So if we focus on them individually, so let's first start with this 3 over 2x minus 3, and I've moved the 3 out of the integral like this here, so it's 3 and then the integral of this 1 over 2x minus 3. Now we talked about how to integrate functions like this in the integrating f ax plus b video, the second video in year 2 integration, so go back to that if you need a reminder. But essentially this 1 over 2x minus 3 is of the form 1 over x, and we talked about that when you integrate 1 over x is equal to the natural log of the modulus of x. So therefore, to integrate this 1 over 2x minus 3, we're going to replace this x here in the natural log of the modulus of x with this 2x minus 3. So it becomes the natural log of the modulus of this 2x minus 3. The only difference is we have to divide by the coefficient of x. So here the coefficient of x is this 2 here. So we have to divide by 2. So this is going to be half the natural log of the modulus of 2x minus 3. Remember, we also need to multiply it by this 3 at the front of the integral that we took out. So 3 multiplied by a half is 3 over 2. So it's 3 over 2, the natural log of the modulus of 2x minus 3. And then if we focus on this integral of 1 over x plus 2, this is again of this form here, this 1 over x, so we sub out this x here for the x plus 2, so it's going to be the natural log of the modulus of x plus 2 like this here. We still need to divide by the coefficient of x here, but here the coefficient of x is 1, so therefore it doesn't make a difference, so therefore this is the answer here. So therefore this integral here, if we add these terms together, is going to be 3 over 2, the natural log of the modulus of 2x minus 3 plus the natural log of the modulus of x plus 2, and then remember the constant of integration at the end. Okay, so we've solved this integral here and it's equal to this expression, and now we need to sub in the limits of 6 and 2. So if we start with the 6, it's going to be equal to 3 over 2 and then the natural log of 2, and then instead of x here it's 6 and then minus 3 plus the natural log of 6 plus 2, and then it's going to be minus, and then we sub in the 2, so it's going to be 3 over 2 and then the natural log of 2 times 2 minus 3 plus the natural log of 2 plus 2. We can do a lot of simplifying here. So 2 times 6 is 12 and then minus 3 is 9. So this is 3 over 2 and then the natural log of 9. And then 6 plus 2 is 8. So this is going to be the natural log of 8. 2 times 2 is 4 and then minus 3 is 1. And then remember there's a minus here. So it's going to be minus 3 over 2 and then the natural log of 1. And then 2 plus 2 here is 4. And then remember this is a minus here. So it's going to be minus the natural log of 4. The natural log of 1 is 0, so this term is just going to go away. And then the natural log of 8 minus the natural log of 4. Remember, when you minus natural logs, it divides the things inside the natural log, so it's going to be 8 divided by 4. So this is going to become the natural log of 2. We have these two natural logs added together, but remember, when we want to add natural logs together, we need the coefficients to be the same. And here we have this coefficient of 3 over 2. So what we're going to do is take this inside the natural log as a power, so it becomes the natural log of 9 to the power of 3 over 2 like this here. Remember what the power of 3 over 2 does. It firstly square roots the 9 and then it raises it to the power of 3. So when you square root 9, it's equal to 3, and then when you raise it to the power of 3, it's 27. So it's a natural log of 27 plus a natural log of 2. So now we can add these natural logs together. So 27 multiplied by 2. Remember, when you add natural logs, it multiplies them together. This is going to be equal to the natural log of 54. And then this is in a single logarithm, which is what's required. So the final answer is the natural log of 54. Okay, so here's another example from a past paper question where for part A, we need to find the value of the constants A, B, and C in the partial fractions, and then in part B, we need to do the actual integration. Okay, so for part A, as I said, we need to find the values of these constants A, B, and C. And this time we've got 3 partial fractions because we've got 3 brackets in a denominator like this. But the process is still the same. What we first need to do is, with this equation, we need to multiply everything by this denominator here. So we need to multiply all the terms by the 3 brackets, 2x plus 1, x plus 1, and x plus 3. So this term here, this denominator will just cancel out and leave us with the numerator 4 minus 2x. This term, this 2x plus 1 denominator will cancel out and leave us with a x plus 1, x plus 3. This x plus 1 denominator will cancel out and leave us with b 2x plus 1, x plus 3. And then this x plus 3 denominator will cancel out and leave us with c 2x plus 1, x plus 1, like this here. So if we first focus on this x plus 1 bracket, so we want x plus 1 to be equal to 0. So therefore we're going to say that x is equal to minus 1. So if we let x equal minus 1, this bracket here will equal to 0, so this term is going to cancel out. And this bracket here is going to be equal to 0, so this term will cancel out. So we're just going to be left with this and this here. So if we sub in x is equal to minus 1, we're going to get this here. And then we can simplify this because minus 2 multiplied by minus 1 is 2, and then 4 plus 2 is 6. And then this bracket here, if you do the maths, is going to simplify to minus 1. And this bracket here is going to be 2, and then minus 1 times 2 is minus 2. So it's minus 2b, like this here, and then divide both sides by minus 2 to get the b is equal to minus 3. So we found the value of b. So now what we're going to do is make this bracket here, this x plus 3 equal to 0. So x plus 3 is equal to 0, so then x is going to be equal to minus 3. So if we let x equal to minus 3, this bracket here is going to be equal to 0, so this term's going to go away. This bracket here is going to be equal to 0, so this term's going to go away. So we're just going to be left with these two terms here. So we're going to sub in x is equal to minus 3 here. We can simplify this. This here is going to simplify to 10. This bracket here is going to simplify to minus 5, and this bracket is going to simplify to minus 2, and then minus 5 times minus 2 is 10, so it's going to be 10c, and then divide both sides by 10, so we get that c is equal to minus 1, like this here. And then finally, we're going to focus on this bracket here, so we want 2x plus 1 to be equal to 0, so 2x is equal to minus 1, so therefore x is equal to minus half, so we're going to let x equal to minus a half. If we do this, this bracket here is going to be equal to 0, so this is going to cancel out, and this term is going to cancel out as well, so we're just left with these two terms here. So if we sub in x equal to minus a half, we get this here, and we can simplify this because this is going to simplify to 5. This bracket here simplifies to a half, and this bracket here simplifies to 5 over 2, and then half times 5 over 2 is 5 over 4, so it's going to be 5 over 4a, and then divide both sides by 5 over 4, so a is equal to 4, like this here. So we found a, b, and c, so therefore we can write this fraction here as the partial fractions 4 over 2x plus 1 minus 3 over x plus 1 plus 1 over x plus 3. Okay, and then for part B, we need to integrate this f of x, which can be written as these partial fractions here. And as we showed in part A, that a is equal to 4, b is equal to minus 3, and c is equal to 1, we can write this here as the integral of these partial fractions, 4 over 2x plus 1 minus 3 over x plus 1 plus 1 over x plus 3, like this here, and we can integrate this. So we have these 3 terms, so let's consider them individually. So if we start with this 4 over 2x plus 1, I've taken the 4 out of the integral here, so it's 4 and then the integral of this 1 over 2x plus 1. As we talked about before, this is of the form 1 over x. Remember, when you integrate this, you get the natural log of the modulus of x. So what we do is we substitute out this x here for this 2x plus 1, so it becomes the natural log of the modulus of 2x plus 1, but we also need to divide by this 2 here, so it becomes a half, like this here. And we need to multiply it by this 4 that we took out, and 4 multiplied by a half is 2. So this is 2, and then the natural log of the modulus of 2x plus 1. And then if we focus on this minus 3 of x plus 1, again taking this minus 3 out, again this will be the natural log of the modulus of this x plus 1, like this here, as the coefficient of x here is just 1. We don't need to divide it by anything, like this here. So it will be minus 3, and then the natural log of the modulus of this x plus 1. And then if we integrate this 1 over x plus 3, it will be similar. It will just be the natural log of the modulus of x plus 3. We don't need to divide by anything. So therefore, if we add these terms together, this integral is going to be 2, and then the natural log of the modulus of 2x plus 1 minus 3, and then the natural log of the modulus of x plus 1 plus the natural log of the modulus of x plus 3, and then remember the plus c on the end. Okay, and then for the second part of b, we need to find this integral here between the limits of 0 and 2. So therefore, into this integral that we found in part b, we need to sub in the lower limit of 0 and the upper limit of 2. And this is what I've done here, and you get out this kind of really long expression, where here is where I've subbed in the limit of 2, and then it's minus, and then this is where I've subbed in the limit of 0. And if you figure this out, it simplifies down to this here, and we can do some more simplifying because we have the natural log of 1 here. Remember, the natural log of 1 is 0, so this term will just go away. It's the same with this one. We have the natural log of 1. We have 2 natural log of 5 plus the natural log of 5, which will be 3 natural log of 5, and then we have minus 3 natural log of 3 minus natural log of 3, which will be minus 4 natural log of 3, like this here. Now we need to write it in the form natural log of k, so we need to get it into a single natural log. And the best way to do this is these coefficients here. What we're going to do is, remember the laws of logs, we're going to bring these into the logs as powers, like this here. So it'd be the natural log of 5 cubed minus the natural log of 3 to the power of 4. 5 cubed is 125, 3 to the power of 4 is 81, and then we have these two logs here, this natural log minus this natural log. So remember laws of logs, you can combine these into one log by dividing what's inside the logs. So therefore, this as a single log here, which will be the natural log of 125 over 81, so k is equal to 125 over 81. Okay, so here's another example involving partial fractions and integration. Okay, so for part A, we have to split this fraction up into partial fractions. And here we have something called a repeated root, where in the denominator, one of the brackets is to the power of 2, like this here. And when we have this repeated root, we have to deal with it in a particular way when we're splitting it up into partial fractions. So what we're going to do with this fraction, we're going to split it up into 3 partial fractions, like this here. One of the denominators is just going to be this 1 minus x here. And this 3 plus 2x to the power of 2, we need to split this up into 2 partial fractions. One of the denominators is going to be this 3 plus 2x to the power of 2, like this here. And the other denominator is just going to be 3 plus 2x, and we have to deal with it like this here. And we have to find a, b, and c, the constants in the numerator. Go back to the video on partial fractions if you need a reminder of when we have repeated roots, why we have to deal with it like this here and why it works. But what we're going to do is just do the same thing now as we've done before, is solve this equation here for a, b, and c. So first what we're going to do is multiply everything in this equation by this denominator here. So we're going to multiply all the terms by the two brackets, 3 plus 2x squared, 1 minus x. So this denominator is just going to cancel out and leave us with the numerator 25. This term here, this 3 plus 2x squared denominator, is going to cancel out with this 3 plus 2x squared bracket here and just leave us with a multiplied by 1 minus x. This 3 plus 2x denominator is going to cancel out with one of the 3 plus 2x brackets here, because remember it's to the power of 2. So the power of 2 will go away, but we're still going to have one left over. So it's going to be b multiplied by 3 plus 2x multiplied by 1 minus x, like this here. And then this 1 minus x denominator is going to cancel out with the 1 minus x bracket and leave us with c multiplied by 3 plus 2x to the power of 2. Remember this power of 2 here. So now we're going to solve this equation for a, b and c using substitution. So let's focus on this bracket here first, this 1 minus x. So we need 1 minus x to be equal to 0, and then if you move the x onto the other side, we get that x is equal to 1. So we're going to let x be equal to 1. So this bracket here is going to be equal to 0, so this term is going to go away, and this bracket here is also going to be equal to 0, so this term here is also going to go away. So we're only going to be left with the 25 here and this term here for c that we're going to plug in x is equal to 1, and then we can simplify this because 3 plus 2 times 1 here is equal to 5, but remember it's to the power of 2 here, so it's going to be 5 squared, which is equal to 25, so it's going to be 25c, and then divide both sides by 25, so therefore we get that c is equal to 1. And then we're going to focus on this bracket here, this 3 plus 2x, so we want 3 plus 2x to be equal to 0, so move the 3 onto the other side, so 2x is equal to minus 3, divide both sides by 2, so x is equal to minus 3 over 2, so we're going to let x equal minus 3 over 2. So here this is going to be equal to 0, so this term is going to go away, and this term here is also going to go away because we've got this bracket, so we're just going to be left with the 25 and this a term here, so we sub in x is equal to minus 3 over 2. This here is going to be equal to 5 over 2, so we've got this here, and then if we divide both sides by 5 over 2, we get that a is equal to 10 here. Okay, so a bit of a problem that we have here is this b term has both of these brackets, and the issue with this is in both cases when we made the substitution x is equal to 1 and x is equal to minus 3 over 2, this b term cancelled out, which means there's no way for us to make an equation that just involves b. There's no substitution that we can make that will cancel out the a term and cancel out the c term and just leave us with an equation for b. It doesn't work like this because of these two brackets, so we have to approach this a tiny bit differently. What we're going to do is this equation here, we're going to sub in the values that we found for a, which is 10, and c, which is 1. So therefore this equation is going to become 25 is equal to, and then we're subbing out this a here for 10, and we're subbing out this c here for 1, but remember we don't have to write this one, so therefore this term here will just become 3 plus 2x squared. So therefore we've only got the b left here. And now what we're going to do is we're going to sub in a value for x. It doesn't actually matter what we sub in, we just need to sub in a value for x, and therefore this will create an equation that only has b in it because we've subbed out the a and the c for the values that we found. So if we just say that x is equal to 0, because this is kind of just the easiest value to sub in, this equation will become 25 is equal to, and then we subbed in x is equal to 0 for all the x values here, and it only involves b, this equation now, so we can rearrange it in order to find b. So if we solve this, this bracket here is equal to 1, so this is going to be 10 times 1, which is just equal to 10. Then this bracket here is equal to 3, this bracket here is equal to 1, so 3 times 1 is 3, so this is going to be 3b, and then this bracket here is equal to 3, but remember it's squared, so 3 squared is 9, so it's going to be like this here. 10 plus 9 is equal to 19, so we've got this 25 is equal to 19 plus 3b. Move this 19 onto the other side, so we get that 6 is equal to 3b, and then divide both sides by 3, so we get that b is equal to 2. So therefore we have found the values for a, b, and c, so therefore this partial fraction can be written as 10 over 3 plus 2x squared plus 2 over 3 plus 2x plus 1 over 1 minus x. Okay, and then for part B, we need to find the integral of f of x, and f of x is this fraction here. And as we showed in part A that it can be split up into these partial fractions, this question is essentially asking us to integrate these partial fractions here. And we can do that. We have these three terms, so let's consider them individually. Let's start with this 10 over 3 plus 2x squared. I've taken the 10 out of the integral like this here, so it's the integral of 1 over 3 plus 2x squared. I'm going to rewrite this as 3 plus 2x to the power of minus 2, as this is easier to get it kind of into the integrated form. So This bracket, we talked about how to integrate brackets like this in the integrating f of ax plus b video, so go back to that if you need a reminder. But we talked about in general that if you want to integrate ax plus b to the power of n is equal to 1 over a n plus 1 ax plus b to the power of n plus 1, like this here. So if we take this into consideration with this here, so this 1 over a n plus 1 is going to be 1 over, and then a here, the coefficient of x is 2, so it's going to be 2 multiplied by n plus 1, so n here is this minus 2, so if we add 1 to this it's going to be minus 1, and then 1 over 2 times minus 1 is equal to minus a half, so this is going to be equal to minus a half here, and then it's going to be this 3 plus 2x, and then it's going to be to the power of n plus 1, which is equal to minus 1. Remember, we need to multiply it by this 10 here at the front, so 10 multiplied by minus a half is equal to minus 5, and then what I've done is I've rewritten this 3 plus 2x to the power of minus 1 as this 1 over 3 plus 2x. I've put it back in the denominator because this is kind of the neater form to write it. And then if we focus on this 2 over 3 plus 2x, again I've taken the 2 out of the integral. When you integrate this here, this is kind of the examples we've already seen in this video. It's of the form of the integral of 1 over x, but we're going to replace the x with this 3 plus 2x, so it's the natural log of the modulus of 3 plus 2x, but remember we need to divide it by this coefficient of x here too, so it's going to be half here, and then 2 multiplied by half cancels out and we're just left with the natural log of the modulus of 3 plus 2x. And then if we just consider this 1 over 1 minus x, this is going to be the natural log of 1 minus x, because again it's of this form here. Remember, we need to divide it by the coefficient of x, which is this minus 1 here, so we're going to have this minus in front of it like this here. So therefore if we add these three terms together, it's going to be this here as the final answer. Minus 5 over 3 plus 2x plus the natural log of the modulus of 3 plus 2x minus the natural log of the modulus of 1 minus x, and then remember this plus c on the end. Okay, so here's another example from one of the newer papers where for part A you need to split it up into partial fractions, and then in part B you need to integrate it. Okay, so for part A, we need to show that this fraction here can be written in this format here. We need to find what A, B, and C are. Now, when you first read this question, it looks quite odd because this format here is not the same format that we've seen so far for the other partial fractions. And the reason is because this fraction here is quite unusual. It's something called top-heavy fraction. And the reason it's called this is because we have this x squared term in the numerator here, but in the denominator it only goes up to x here. We don't have an x squared, so it's a top-heavy fraction because the polynomial in the numerator is a higher degree than the polynomial in the denominator, so therefore we kind of write this instead as this ax plus b without kind of any denominator here dividing it. So how do we actually solve this? Well, when it's this top-heavy fraction, there's a couple of ways that you can do this, but I think the easiest way is to use algebraic division that we talked about back in year 1 in chapter 7. So go back to that if you need a reminder of how algebraic division works. But essentially what we're going to do is algebraically divide x squared plus 8x minus 3 by x plus 2. So the way that we do this is firstly we divide this x squared here by this x, and x squared divided by x is just x like this here, and then we multiply this x by this x plus 2, which is going to be x squared plus 2x, and then what we're going to do is minus this x squared plus 2x from this x squared plus 8x up here. So this is going to be equal to, so x squared minus x squared is just going to cancel out and it's going to be 0, and 8x minus 2x is equal to 6x like this here, and then this minus 3 we're going to bring it down here with this 6x here, and then we're going to divide this 6x by this x here, so it becomes plus 6, and then we're going to multiply this 6 here by this x plus 2, so it becomes 6x plus 12, and then we're going to minus this 6x plus 12 from this 6x minus 3. So these 6x is going to cancel out and leave 0, and then minus 3 minus 12 is equal to minus 15, like this here. So what we've actually done here is we've divided the x squared plus ax minus 3 by this x plus 2, and it's given us an answer of this x plus 6 here. And then this minus 15 is the remainder, and what we do is we kind of keep this divided by this x plus 2, like this here. So we write it in this format here, and this is actually in the correct format of this question here, this ax plus b plus c over x plus 2, where a is equal to 1, this is the coefficient of this x here, which is just 1, and then b here is 6, and this c is minus 15. So this here is the final answer. Okay, and then for part B, we need to find the exact value of this integral between 0 and 6 of this fraction here. We need to give our answer in the form a plus b and then the natural log of 2. And as we showed in part A, that this fraction can be written as this here, with a equal to 1, b equal to 6, and c equal to minus 15. This question is essentially integrate between 0 and 6 this x plus 6 minus 15 over x plus 2. Okay, so let's solve this integral here. Okay, so as it's a definite integral, we don't need to worry about these limits at the start here. We first need to actually focus on integrating this x plus 6 minus 15 over x plus 2. So let's do this. So we have these three terms, so let's consider them individually. If we start with this x here, this is just simple year 1 integration. When you integrate x, it's equal to half x squared, and similar, if you integrate 6, it's just equal to 6x, like this here. If you integrate this minus 15 over x plus 2, I've taken the minus 15 out of the integral, like this here. So we need to integrate 1 over x plus 2. This is of the format that we've seen before, where it's the integral of 1 over x. So it's going to be the natural log of the modulus of x plus 2. We need to divide it by the coefficient of x as well, but as this is 1, it doesn't make a difference. Remember to multiply it by this minus 15 at the front, so it's going to be minus 15, and then this natural log here. So therefore this integral is going to be these terms added together, so it's going to be half x squared plus 6x minus 15, and then the natural log of x plus 2, and then remember the plus c on the end. So now we need to plug in the limits of 0 and 6 into this expression here. So if we do this, it kind of gives this really long and horrible kind of expression here when we plug in 6 and then we minus and then we plug in the 0 as x. So let's simplify this. So we start with this half and then 6 squared. So 6 squared is 36, and then 36 divided by 2 is 18, so this is going to be 18, and then 6 times 6 is 36, like this here. This is going to be 15, and then the natural log of 6 plus 2, which is 8. This here is just going to be 0, this here is also going to be 0, and then this here is going to be minus 15, the natural log of 0 plus 2, which is equal to 15, and then the natural log of 2, like this here, and then 18 plus 36 is equal to 54 here. Now we need to give our answer in the form a plus b and then the natural log of 2. So we have a natural log of 2 here with this 15 natural log of 2, but here we have 15 natural log of 8. So we need to write this in the form natural log of 2, and we can do this because remember that 8 is equal to 2 cubed. So what we can do, remember the laws of logs, we can bring this 3 to the front of this log here, so it becomes 15 multiplied by 3 natural log of 2, so we can write it like this here, and then 15 times 3 is equal to 45. So this is 45 natural log of 2, so we can write it like this here, and therefore we can simplify this because we've got minus 45 natural log of 2 plus 15 natural log of 2, which is equal to minus 30 natural log of 2. So this is in this form here, a plus b natural log of 2, where a is equal to 54 and b is equal to minus 30. Okay, so here's one final past paper question for you to have a go at. So pause the video, have a go, and I'll go through the answers in about 5 seconds. Okay, Okay, so for part A, we need to express this fraction here as partial fractions, and as we've got these two brackets in the denominator, x plus 4 and x minus 2, we're going to split these up into two partial fractions with the numerators a and b, and we need to find what a and b are. So firstly, we're going to multiply everything in this equation by the denominator here, so we're going to multiply everything by the brackets x plus 4, x minus 2, so this denominator here will cancel out and just leave us with the numerator 3k x minus 18. This x plus 4 denominator will go away, so we're left with a multiplied by x minus 2, and then this x minus 2 denominator will cancel out to leave us with b multiplied by x plus 4. So what we're going to do now is use substitution on this here. So if we first focus on this bracket, we want x minus 2 to be equal to 0, so therefore we want x to be equal to 2. So if we sub in x is equal to 2, this term here will go away, so we'll be left with these two terms here. So it'll be 3k, and then instead of x it will be 2 minus 18, and this is equal to b, and then 2 plus 4. 3k multiplied by 2 is 6k, and 2 plus 4 is 6, so it's going to be 6b, and then we're going to divide both sides by 6, so we get that k minus 3 is equal to b. And then if we focus on the other bracket, which is this x plus 4, so we want x plus 4 to be equal to 0, so therefore if we bring the 4 onto the other side, we get that x is equal to minus 4. So if we let x equal to minus 4, this term will just go away, and we're left with these two terms. It's going to be 3k minus 4 minus 18 is equal to a, and then minus 4 minus 2, like this here. 3k multiplied by minus 4 is minus 12k, and minus 4 minus 2 is minus 6. It's going to be minus 6a, and then divide both sides by minus 6, so we get that a is equal to 2k plus 3. So we found a and b, so therefore we can express this fraction using the partial fractions 2k plus 3 over x plus 4 plus k minus 3 over x minus 2. Okay, and then for part B, we need to find the exact value of k for which the integral between minus 3 and 1 of this fraction here is equal to 21. And as we showed in part A, that this fraction can be split into these partial fractions here, we can rewrite this question as find the value of k when the integral between minus 3 and 1 of these partial fractions here is equal to 21, and therefore it's a lot easier to do. So this is a definitive integral, so as I talked about before, we don't need to worry about these limits at the start. What we first need to focus on is actually integrating this here. So let's consider these two terms individually. So if we start with this 2k plus 3 over x plus 4, remember 2k plus 3 is a constant, so therefore we can take it out of the integral like this here and focus on integrating this 1 over x plus 4. And this here is really easy. We've seen it loads of times in this video already. It's of the form 1 over x, so therefore when we integrate it, it's going to be the natural log of the modulus of x plus 4. Again, we divide it by the coefficient of x, but as it's 1, it doesn't make a difference. And then remember this 2k plus 3 at the front. And then if we consider integrating the k minus 3 over x minus 2, again I've taken the k minus 3 out of the integrals, it's a constant. If we integrate this here, it's essentially the exact same. It's going to be the natural log of the modulus of x minus 2, and then remember this k minus 3 at the front. So therefore this integral is going to be these terms added together, so it's going to be 2k plus 3, the natural log of x plus the modulus of x plus 4, plus k minus 3, and then the natural log of the modulus of x minus 2, like this here. So now we need to plug in the limits of 1 and minus 3. So if we do this, so if we consider 1 first, so it's going to be 2k plus 3, and then the natural log of 1 plus 4, so this is going to be the natural log of 5. And then this here, if we plug in this 1, this natural log is going to be 1 minus 2, so it's going to be minus 1, but remember we have these modulus symbols around it, so therefore it's going to be the natural log of 1, and the natural log of 1 is 0, so therefore this term doesn't exist for when we plug in 1. And then if we plug in minus 3, it's going to be, so remember we're going to minus it, it's going to be 2k plus 3, and then the natural log of minus 3 plus 4, which is going to be the natural log of 1, so that's not going to exist. And then it's going to be k minus 3, the natural log of minus 3 minus 2, so it's going to be the natural log of the modulus of minus 5, so remember it's going to be the natural log of 5, like this here. Okay, so we need to find the exact value of k. So we've got the natural log of 5 in both terms. So what we can do is divide everything by the natural log of 5 and get that 2k plus 3 minus this k minus 3. Remember to put these brackets around the k minus 3 is equal to 21 divided by this natural log of 5. So this here will be 2k plus 3, and then it will be minus k plus 3. We're going to expand this bracket here. 2k minus k is equal to k, and then 3 plus 3 is 6. So we've got this k plus 6 is equal to 21 over the natural log of 5, and then if we move this 6 onto the other side, we get that k is equal to 21 over the natural log of 5 minus 6. It wants the exact value of k, so we're going to leave it in this form here, and that's the final answer.